Inequalities, as you may remember from GCSE, are expressions where we may not have a singular value for x for which it works, but rather a range of values. And just to kind of explain what I may mean by that, it's probably best that we just go straight into the notation that you're going to be using for inequalities. So we could have that x is followed by any one of these four symbols here. This one would mean that x is less than, and below that with the extra line, that would not only mean that x is less than, but it also means or equal to. So if we just simply had x less than 2, it means that there isn't a one value for x for which that is true. It could be any possible value so long as that value is less than 2. And then the only difference with the additional line is that it could now equal 2 as well. Again, so long as it's just not greater than it. Then on the other side, just the reverse, we now have x is greater than. And similarly, below with the extra line underneath that you just want to account for, not only is it x is greater than, but it's also or equal to. So we could have maybe that 2x is greater than 6. Right? And if 2x is greater than 6, then what you can say is by dividing both sides by 2, x is greater than 3. So the solution will be any value of x which has a value that is bigger than 3. There's nothing specific other than that. And yes, as I just kind of implied there, we're going to be treating this with the exact same kind of rearranging or rewriting rules that we would any other regular equation, as if it was an equal sign. An extra little bit we're going to have to consider will come up when we get onto the quadratics, but if we just start with something a bit more linear. So, below here, if we're saying find the sets of values of x for which, and first of all, 3 in brackets 2x plus 1 is greater than 5 minus 2x. So here clearly it's already slightly different to the example I was just coming up with a second ago, because we have x and multiple terms on both sides. So if this was just a regular equation with an equal sign, you would bring the x's together and the non-x's together on the other side. We're going to do the exact same here. First of all, actually though, we probably want to expand these brackets. So 3 times the 2x would end up being 6x, and 3 times the 1 is just 3. So 6x plus 3 is what's greater than 5 minus 2x. Then move the 2x onto the left-hand side. It's a minus here, so it will become a plus. So 6x plus 2x, that'll end up being 8x. Then we'll move this 3 over to the right-hand side. It's a positive here, so it'll become a negative over there. So 5 minus 3, we've now got 8x is greater than 2. And if 8x is greater than 2, then we can divide both sides by 8, because whatever you do to one side, you have to do to the other. That leaves x being greater than a quarter. And if you wanted to test that, you could just start plugging in x values into the original. So if you picked a number that was greater than a quarter, like just 1, or any pick a whole number, you would find that this is true. But if you picked anything smaller than a quarter, then you would find that it wasn't true, that the left-hand side would likely be less than the right-hand side instead. Now then, for that quadratic that I alluded to before, again, if this was just a regular equals 0, then how we go about this is we would factorize. When putting something like this into double brackets, we're going to need to put 2x at the start of one bracket and x at the start of the other, because they need to times together to make 2x squared. And then the numbers at the end have to times together to make 3. Well, presumably we're going to be working with whole numbers for now. So the only numbers that would then make times to make 3 are going to be 1 and 3 themselves. But what order to put them in order to make this minus 7x in the middle? Well, when we expand, whatever number is here on the right-hand side is going to be times by this 2 here. It's going to be doubled. So either the 1 is going to be doubled to make 2, or the 3 is going to be doubled to make 6. So how can we make 7? Is it going to be the 3 and the 2, or the 1 and the 6? Well, it's going to be the latter, the 1 and the 6. So we need that our 1 to be here and remember the 3 is the actual number that goes here. The 6 is just because in the expansion it gets doubled like this. And to then finally make it a minus 7x, you would need a minus on both of these. Now again, if this was just a regular equal sign, what we would say here now is that two things are times together to equal 0, therefore one of them must be equal to 0 itself. Therefore, if 2x minus 1 equals 0, then x would have to equal a half. Or if x minus 3 equals 0, then that would mean that x would have to equal 3. This, however, is not an equal sign. No, it won't be for this entire kind of topic. So we have to work out, well, is x going to be greater than these values or less than these values, or between them on the outside? This here is a positive quadratic. Therefore, its graph has to be a parabola. It's like a U shape here. Now, what you have done when you found these factors is you have found where this graph is going to cross the x-axis. So you found that this is going to cross here at half, and then this is going to cross here at 3. To work out, therefore, for which regions this graph is greater than 0, well, if we look here, the line is greater than 0 for this bit here, because now we're above here, or to the right here, because it's up here. If we were to go between these values, that would bring us below the x-axis, less than 0. So, in general, if you make your quadratic a positive quadratic, bring it onto the same side so the first number is positive, I'd always suggest that, you're going to know that your graph is going to be this U shape here, and so if it's looking for greater than 0, what we'll have to say is that x is less than the lower number, so in this case less than half, but then it's greater than the higher number, so x is greater than 3, or in this, how I've written it, 3 is less than x. If it had been less than 0 here, then you would have gone in between them. So x is greater than half, but less than 3. And also, just to be clear here, we do have to write these as separate inequalities, rather than just doing something like so 3 is less than x is less than a half, just to try to get it all the same way, because that would then imply that 3 is less than a half, which isn't true. We need to acknowledge them as separate scenarios. Okay. Then once we have this, we can now say, well, for which values of x would both of these be true? Well, because we know from the left-hand one that x has to be greater than a quarter, and from the right-hand one, x either has to be less than a half or greater than 3, or to combine these, what we'd say is that, first of all, x can be either between a quarter and a half, because it'll be greater than the quarter here, but then less than a half here, or it still can be greater than that 3. Okay. Yeah, so if you were just to maybe draw out a number line or something and you shaded in the regions, you would find, yes, these are the x values for which they work. Again, also you can just do a little bit of plugging the values back in to double check. If you were to pick a value that was between a half and 3, while that might work for the left-hand equation, it doesn't work for the right-hand one. If you were to pick a value that was less than a quarter, while it may work for the right-hand one, it won't work for the left-hand one. The only times that x works is when it's between the quarter and a half, or just greater than 3, because these are the inequalities that fit both criteria. Okay. Well, if we're happy with that, if we can just understand the distinctions between these signs and how we can then rearrange around the inequality sign to come to solutions, factorising and then potentially drawing it out graphically if needs be for a quadratic, and how to combine those together, let's just see how you could get along with an example of your own. So, in a very similar manner to the one we just did, find the sets of values of x for which 4x minus 3 is greater than 7 minus x. Then 2x squared minus 5x minus 12 is less than 0, and then find the values of x for which both work. Okay? Pause the video, have a go for yourself, and then press play again when you're ready to compare. Alright, so with the first one, the linear one, because it's all just a single power of x, this will be like how we just treat rearranging a regular formula, in that you'll bring all the x's to one side, the non-x's to the other side. So we'll add this x over, because it's a negative here, so it'll become a plus. So 4x add x gives us 5x, and we'll move this 3 over here, because it's a minus here, it'll become a plus on the other side. So 5x is greater than 7 plus 3, which is 10, and then if you just divide by a common factor of 5, you're left with x greater than 2. Then, for the second one, again, because this is a quadratic, because we have a square, we're going to break this down into two brackets. Once again, we're going to have to start those brackets with 2x and x, so that they can times together to be 2x squared. But now, if we're trying to find numbers that will times together to make 12, yet also then help to make 5 in the middle, well, for this, we maybe want to start by just listing out the factors of 12. Okay, so we've got 1 and a 12, 2 and a 6, 3 and a 4. But then remember, whichever one goes on the right-hand side is going to end up being doubled. So it's either going to be 1 and 24, or 12 and 2, 2 and 12, or 6 and 4, 3 and 8, or 4 and 6. Well, which of those have a difference of 5? That would be the 3 and the 8. Therefore, in your brackets, you're going to put a 3 on the left and the 4 on the right, so that it's the one that's doubled by the 2 in the expansion. And because we're trying to get a negative 5, what you would want is a positive 3 and a negative 8, so 2x plus 3 and x minus 4. From this then, if it was an equal sign, you'd end up with x equals minus 3 over 2, or x equals 4. But because this is an inequality, we may just want to draw out the parabola, where now we're having this point of intersection being the minus 3 over 2, and this intersection here being the 4, that solution. Because we want to be less than 0, we're now looking for the bit that's beneath the x-axis. That's between your two values. Therefore, your solution would be x is greater than the minus 3 over 2, but then less than the 4. And because this does work mathematically, you can do them all at once, because minus 3 over 2 is indeed less than 4. Then, just to wrap up, what would be an expression for the inequality for which both inequalities work? Well, this is the only upper bound that we have, so we can keep that as our kind of upper bound here. But then, comparing the lower bounds, either x has to be greater than 2, or it has to be greater than the minus 3 over 2. Well, the higher lower bound is the 2 here. So we'll put that there. If we were just to insist that x has to be greater than the minus 3 over 2, that could mean that x could be minus 1, and minus 1, for instance, wouldn't work with that top expression. So yes, just to clarify, when you have like your multiple inequalities that you're going to merge together, you want the highest lower bound and the lowest upper bound, if it could come together as a single thing like this, rather than your separate inequalities like we had from the previous example. Okay, again, if we're happy with that, there's just another type of inequality question we're now going to look at, and that's going to be representing these graphically with then shaded regions from which we can then find maximum values and minimum values and so forth. Now, before we just scroll on to that, just while I can see the symbols and notation up here, I just want to show how the lines are going to look. When on a graph on some axes, you wish to show an inequality involving just like a less than or a greater than sign, that is going to look like a dotted line here, okay? To show that it can't actually equal the value that is on that line itself. However, if it isn't or equal to, then you'll plot it with a solid line. Okay, cool. Just to make that distinction clear first of all, so that now, as we scroll down to these other kinds of questions, we'll understand why we potentially are drawing these in different ways. So, in our first scenario here, we have that Triago does some work during the holidays. He spends X hours cleaning cars and Y hours repairing bikes. The time spent repairing is at least equal to the time spent cleaning. He spends no more than 12 hours working, but spends at least 4 hours cleaning. Write down 3 inequalities from this, then draw them on axes, shading any unwanted regions. If he then earns $3 per hour for cleaning and $1.50 per hour for repairs, what is the most and then the least that he could earn within these parameters? So, to start off with, just to write down the 3 inequalities, we have to find them from the statements. Because X is going to be representing the cleaning and Y is going to be representing the repairing, if we're saying that repairing is at least equal to the cleaning, well then that's saying that Y is greater than or equal to X. So the repairs can equal the cleaning, but it can also be greater than it because it's at least that time. Right? Then next we have that he spends no more than 12 hours working, so that's in total. Therefore, if you were to combine the number of hours spent cleaning and the number of hours spent repairing, that is to say X add Y, that would at most be 12. Therefore, the X add Y is less than or equal to 12. It could be less than it, and it can be 12 itself, but it's not more than it. And finally, he spends at least 4 hours cleaning. Well, the cleaning was the X, so we'll say that X is greater than or equal to 4. He could spend 4 hours cleaning, or he could spend more than that, but it can't be less. Okay, now that we have these inequalities, now would come the time to draw your axes. So because we know that the total number of hours involved is 12, our axes need to go 12 in both positive directions. We're not going to go into any negative quadrants because you can't have negative time, so we'll just be looking at y-axis and x-axis here in an L shape. But yeah, at most they need to go to 12, because if x was 0, which is the least amount of time that could be spent cleaning, then the y would have to be 12 to make this true. And if the y was 0, saying it spent 0 time repairing, then x would have to be 12 to make this true. So just drawing up some axes here and saying, so you can have 0 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on your x and your y axes. Now to plot these on one at a time. For your y is greater than or equal to x. Okay, so first of all, because these are all greater than or less than or equal to, these are all going to be solid lines per what was said above. And here, if we imagine this was an equals sign, if it was just y equals x, well, that's the diagonal that goes from 0, 0 up to the top corner. Because again, when your x and y values are being the same consistently throughout, so it will look like this. But because y then wants to be greater than x, that means we want to be in this upper region here. Because like 12 is going to be greater than 2 or so forth. But you wouldn't want it as the y being 1 when x is 2. So either way, we're shading the unwanted region. We're not looking for this region down here, because this works when we're above. So we're now ignoring everything on this bottom right-hand side. Then, if we're looking for x add y to be less than or equal to 12, I said before, when x is 0, that means y has to be 12, and when y is 0, that means that x has to be 12. Therefore, this is going to end up being a downwards diagonal line like so, wherein, obviously, so when x is 2, y would be 10, when x is 5, then y would be 7, and so forth. Again, because we're looking to be less than or equal to this, we don't want this to be above. We wouldn't want it to be 12 and 12, which would be 24, because that's too big. So we're now going to shade in all of this top region here. And finally, we have that x is greater than or equal to 4. Because this is only in terms of x, it's just going to end up being a vertical line through the x-axis. So you'd find that x is 4, and you'll just draw a line straight up like so. And because we're looking for x to be greater than or equal to it, we don't want it less, so you'd shade in the unwanted less than bit. Thus, we are left with this little triangle here in the middle, which you may usually be asked to label as R. If you want, we can just like shade it in for the moment, just in a highlighter, just to make it clear that, yeah, this is the spot we're looking at right in the middle. You are always going to get some kind of enclosed shape. You should never really have it, or I wouldn't expect to be one of these larger regions over here. It's more of a small one in the middle. So then, how can we use this to work out what's the most and least this person could earn, given that they get £3 an hour for cleaning and dollars and $1.50 per hour for repairs? Well, what we can say is the most and least are always going to be on one of the corners of the shape that you make for your center region. It's always going to be on a corner. So if we actually just first will read off what these are going to be. So this corner up here, that's going to be when x is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, which makes sense because it's on the line where if you're on that red line itself, they need to combine together to make 12. So your 6 and your 6 being 12. Obviously mine is just a sketch, it's not perfectly to scale, but that is what you should get if you were doing this accurately. And here, what we should have found is that this is obviously going to be 4 on your x-axis, and that really should have lined up with your 4 here, which again, if you want to double check, if your y is greater than or equal to x, at least the least thing that the y could be is equal to the x itself. So if your x is 4, then the y would be 4 as well. And finally, this corner up here, again, your x is going to be 4, but now you should find that that would end up being 8, because again, because on the red line, at most, they're going to combine together to make 12. So if the x is 4, then y has to be 8. So to find the most amount of money, what we're going to be doing is taking your x values and timesing them by 3, then adding that to your y values times by your 1.5. So we're either going to have a 6 times 3 plus 6 times 1.5, or we're going to have a 4 times 3 plus 4 times 1.5, or we're going to have 4 times 3 plus 8 times 1.5. Well, if we work out each of the total values of these corners respectively, what you find is that for the first one, we end up with $27. For the second one, we end up with $18. And then for the third one, we have $24. What then is the greatest amount of money that this person could get? Well, that's going to be the 27, that's your most, and the least is then the 18. You don't have to specify what hours these would be for, but if you did, let's say again, for the most, what you'd have to work out 6 hours of each. And then for the least, you're saying you do 4 hours of each. Okay? So again, it's still using this idea of inequalities, but now we're going to be representing them graphically by drawing the lines onto our axes, shading in the regions, seeing what's left, and then acknowledging that your greatest or least value is going to be on a corner. So, with that in mind, let's again just see how you could get along with an example of your own. So we have here that Ali buys X rose bushes and Y lavender bushes. He buys at least 5 rose bushes, at most 8 lavender bushes, at most 15 bushes in total, and more lavender bushes than rose bushes. So from this, first of all, we want to write down 4 inequalities from this information, and then we need to draw these lines onto the grid, and then so label the region R where all of them are true. You may again wish to shade in the unwanted regions, but it's not explicitly telling you to this time. And then finally, given that rose bushes cost $8 each and lavender bushes cost $4.50 each, what's the greatest amount of money that Ali could spend? So, pause the video, have a go for yourself, and then press play again when you're ready to compare. Alright, so first of all, to write out those inequalities, because the rose bushes are represented by X, we'll say that if we have at least 5 rose bushes, then we'll say that X is greater than or equal to 5. And if there are then at most 8 lavender bushes, and lavender is represented by Y, then Y is less than or equal to 8. At most, it could be 8, but it can't be greater than it. Could be less though. Then, if there are at most 15 bushes in total, that means if you were to combine the x and the y, that could be less than 15 or equal to 15, but not greater than it, so it's less than or equal to 15. And then, if there are more lavender bushes than rose bushes, then we'll say that y is greater than or equal to x. To then draw these on your axes, so if we start off with the x is greater than or equal to 5, because it's just in terms of the x, we'll just be going vertically through the x-axis, so you find your 5, and with your ruler you would draw a line coming straight upwards, and because we're looking for x to be greater than or equal to 5, we'll just shade in the left-hand side that we don't need. And next, if y is less than or equal to 8, well, again, now on the y-axis, going horizontally, we'll find the 8, and you then draw across, and then because we're looking for y to be less than or equal to 8, you would shade in the unwanted upper region. For x and y together then to be less than or equal to 15, like we had before, we say, well, if one of them is 0, that leaves the other being 15, and vice versa. And so we'll end up with a straight line diagonally going between them. So if x is 14, y is 1. If x is 4, then y is 11, and so forth. And because we want to be less than this, you'll then shade in all of this region above that you don't want. And so finally, we then have that y is greater than or equal to x. So again, that is again what we had previously. So that would just be going from the origin to the upper right-hand corner with each x equaling each y. So that will just come down like so. Again, because we're looking for x to be greater than, y to be greater than or equal to the x, we'll shade in the region where it would be less than, which is below. Thus, we have this region here, which is now indeed explicitly asking us to label R, which, again, I'm just going to highlight for our sake here, just so we can more specifically see what it is. This region here that fits all of them, where your corners would be here, 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 and here are 4 corners this time. Now then, if rose bushes cost $6 each and lavenders cost $4.50 each, we'll be doing 6 times whatever the x value is, and 4.5 times whatever the y value is. Now, it would seem if we're trying to get the greatest amount, we'd look maybe at the one that's furthest to the right, because that's going to be the greatest in the x direction. However, here, that value comes out at 7.5 and 7.5, which again would also make sense because it's the intersection of the line where the y would equal the x. They have to be the same value, but they also have to add together to make 15, and so half of 15 is 7.5. You cannot buy half of a bush though. Therefore, we're actually now going to ignore that point, and instead we'll move over to the next right-handmost point, which will be here, which is indeed on 7 and 8. And again, if you just want to confirm that, it's definitely lying on the line of y equals 8, and also on the line where they add together to make 15. So if y is 8, then x has to be 7. Therefore, we're going to have 7 times the 6 for 7 lots of the rosebush, and add to that 8 times the 4.5 for the $4.50 for each lavender, and together that's going to come to a total cost of $78. We could check with the other points if we wanted to as well, so at 5 and 5 and 5 and 8, but in both cases those are indeed going to get you less money. Therefore, that is the greatest. It is still on a corner, and more importantly this time, it's a whole number of each kind of bush.